Unit 7B. And now we're dealing with probabilities and independent events and dependent events and overlapping events. So here we go. Let's do one. Determine whether the events A and B are independent. A balanced die is rolled twice. Event A, 6 comes up on the first roll. B, 6 comes up on the second roll. Well, those are two independent rolls, so we're talking independent events, and that's B, and you can find that on page 429. Now, next incident, we've got to find the probability. You are dealt 2 cards successively without replacement from a shuffled deck of 52 playing cards. Find the probability that the first card is a king and the second card is a queen. Well, you've got 4 chances in 52 of drawing a king. After you draw a card, you've got 4 chances in 51 of drawing a queen, because there's only 51 cards remaining. And so 4 over 52 reduces to 1 over 13, and this product is their independent events, and this product is 4 over 663, which is C, independent events. For 3, find the probability of rolling 3 successive 2s with 3 rolls of a fair die. Well, the probability, and these are independent events, and the probability of rolling a 2 is 1 over 6, but we're going to do this 3 times, and so that product is 1 over 6 cubed, which is 216, and in decimal form we get 0.004630, and B is our guy. Now 4, a card is drawn at random from a deck of cards. Event A is the card obtained is that the card obtained is a face card, and event B is that the card obtained is a spade. Well, a spade can be a face card. There's, and or a face card can be a spade. So that's their overlapping events, and that's B. For so we have our B there. Now for 5. We've got another dependent event situation, or a dependent event situation. A fair die is rolled. What is the probability of rolling an odd number or a number less than 3? Well, the probability of rolling an odd number is 1 over 2. There's 3 odds and 3 evens. The probability of rolling a or a number less than 3, well, there's 2 numbers less than 3, so 2 over 3, 2 over 6 reduces to 1/3, so we have 1/2 plus 1/3, and minus the probability of both occurring, and there's only 1 number less than 3 that is odd, and that's 1, and so the probability of that occurring is 1/6, so we have 1/2 plus 1/3 minus 1/6, which equals 5/6 minus 1/6, which is 4/6, reduces to 2/3, and that's C. By the way, that information, the associated information is on page 433. Now for 6, we've got to use the at least once rule, and that is on page 434. Please look at that. And so find the probability of getting at least 1 tail when tossing 6 fair coins. Well, the probability of getting a tail is 1/2, so we've got 1 minus 1/2 raised to the 6th power. You'll see that formula on page 434. And so 1 minus 1 to the 6th power is 1, but 2 to the 6th power is 64, so 1 over 64. And that simplifies when you get a common denominator, 63 over 64, which is 0.984, and D is our guide. Now for 7, we are given the age of retirement and the associated career table, and we're told that suppose that one of these people is selected at random. Compute the probability that the person selected at random was an attorney and that they retired between 61 and 65. Round your answer to the nearest thousands. Well, there's 77 attorneys between the age of 61 and 65, and we've got a total of 680 people, so the probability is going to be 77 over 680, which equals 0.13, and that's selection D. Now finally for 8, a knight, provide an appropriate response. A knight may win a tournament. He may also fail to win the lady of his love, the love of his lady. Are these events overlapping? Why or why not? Yeah, they're overlapping. And here's why. Here's a Venn diagram. We have the knight wins the tournament, and the knight wins the lady. And if it overlaps, well, the knight has won both the tournament and the lady. If it doesn't overlap, the knight's won the tournament but not won the lady. And so why are they overlapping? They are because, yes, they are overlapping because not all ladies love winners. And so he may fail to win the lady. Why? Because not all ladies necessarily love winners. So C, and we are done.